Question 16133, it says that a water leaves the impeller of centrifugal pump with a velocity of 25 meter per second and acceleration of 30 meter per second square. And it also says that both measured relative to impeller along the blade line AB. So it's kind of give the direction as well. Determine the velocity and acceleration of a water particle at A. So we have to find velocity and acceleration of water particle at A, which is at the top over here at the boundary of this propeller. As it leaves the impeller at the instant shown, the impeller rotates with a constant angular velocity omega is equal to 15 radian per second, and the angle it shows with the horizontal of AB is 30°, and the radius of the impeller shown is 0.3 meters, and the direction of angular velocity is clockwise. So in our question we have to take a reference point to get to A, so we choose the central point O, and we know that its velocity and acceleration is 0 because as in the question it is mentioned that it is a fixed point, so that's why it is 0. And its angular velocity is given, which is clockwise, which is 15 radian per second, and its angular acceleration is 0 because it says that constant angular velocity, which means that it's staying constant, so angular acceleration is 0. So to find the velocity at A, first we use the formula, which is velocity at A is equal to velocity at O plus omega multiplied by R, which is A relative to O, plus V relative and XYZ. So we know that VO is 0 and omega is 15, which is minus because of the clockwise direction, and it's K, and R A relative to O is 0.3J because it's in the vertical direction from O. A is in the vertical direction from O, which is 0.3 because it is the radius of the impeller. And then V relative XYZ, it's already given in the question that it is the velocity is 25 and it is in the direction of AB, and we are given with AB which is in the 30-degree direction. And so we draw the right angle triangle in which the hypotenuse will be 25 and this angle, so we break this 25 into its components, which is minus 25 cos 30i. Minus is due to the horizontal direction, which is going towards left, and positive y direction because it's moving upwards then. And then we put in the values, we use the cross product over here. K into j is I minus I, and this minus cancels at minus, so it's become 4.5i minus 21.65i plus 12.5j, and then we add them and we get the velocity in form of the I and j components. Then we have to find the acceleration, so we put in the acceleration formula, which is acceleration at A is equal to acceleration at O plus angular acceleration multiplied by R, which is A relative to O, plus omega square multiplied by R A relative to O plus 2 omega multiplied by the relative velocity plus the relative acceleration. So we know that the acceleration at O is 0, the angular acceleration is also 0, so this whole term over here will be equal to 0. And then omega, which is given, which is 15, we square that. R A relative to O is 0.3j. Then we put over here omega, we put the value of omega, same with velocity as before. And for acceleration, it is given in the question that the relative acceleration is 30 meter per second square, and also its direction is same as velocity. For we do the same triangle formula, right angle triangle trigonometric ratios, and we get minus 30 cos 30i plus 30 sine 30j. And then we just do the maths over here and the cross product over here of I and j components, and finally we get minus 67.5j plus 649.5j plus 375i minus 25.98i plus 15j, and then we further simplify it into 349.02i plus 597j. So we further simplify it by taking only the first three significant numbers, which is 345i plus 597j meter per second square, which is the acceleration at A of the water particle, and this is the velocity at A of the water particle.